Okay, so solving equations with unspecified constants. You know what a constant is, right?
A number that stays the same.
Stays the same, right? And so these are going to be equations really without numbers in them so much, right? And the numbers, if we know what they are, we can add them together, subtract them, or whatever. But if we don't know what they are, we just kind of have to leave them as the letter they are. And these are also known as literal equations. Yeah. So literal equations. And you find a lot these, a lot in science and whatnot, where you have formulas for things, okay? You just plug in certain numbers. But let's take a look at an example, one we're pretty familiar with, right? So in A, we know what to do here, right? You solve this for x. Yeah, you would do it in your head, can't you, almost by now? So you get 5x equals 30, and divide by 5. So x equals 6, right? So we could do this actual subtracting 3 from 33 because we know what the numbers are, right? And then in the 5x divided by 5, because we know what the numbers are, 30 divided by 5. But over here, you can see this kind of looks like this, right? This looks like mx plus b still, right? But let's go through and solve this. So our answers are going to be not in terms of numbers, but in terms of letters, okay, instead of numbers, because we don't know what they are. So we have to kind of leave them be. So we would do what to both sides first? Subtract b, right? Just like we normally do. Ax equals, so all we can do here is just whatever c, and we don't know what c and b are, so we just have to write just c minus b, whatever they end up being if you ever plug something in, right?
Divide by a.
Right? And then we would divide both sides by a.
X equals c minus b over x.
C minus b, it looked like an underscore, divided by a. And that's all we can do with it, right? Does that confuse anybody? Right? What's the matter? So again, we don't know what the values of a, b, and c are, so we just have to leave them like that for when we do get numbers to plug in, then we can do the subtraction and division, right? Let's look at some other ones here. Let's see, solving two equations. So this one again is going to have we'll have a numerical answer, and this one's set up kind of like it, right? So over here, what would we do first? Say again? No.
Add 7.
Add 7 to both sides, right? And so we get x plus 5 divided by 2 equals 10. And now what? Multiply both sides by 2, right? And we get x plus 5 equals 20. Can we subtract 5? Yeah. And you get 15. Again, we knew the numbers, right? So we can actually combine, add, subtract, multiply, divide them, right? But in part B, it looks a lot like this. But let's see what it looks like when we get done, then there's no numbers. So what should we do over here? Add c to both sides, right? Solving it for x, obviously, right? So we get x plus a over b equals what? D plus c. And now what do we do?
Multiply by b.
Okay, both sides. But be careful. I got to multiply the entire side by b, don't I? Right? So what do we get on the left-hand side? Plus a equals, I'll just rewrite this like this. Just switch it around a little bit. Yeah? What's the matter? Did I lose it?
Yeah, I don't even
Which
have
part?
one up there. The one up top. Top of that.
Okay. Well, you come back to it. So I'm doing the same thing I did over here. I added 7 to both sides. Well, it's just a c, so I'm adding c to both sides. And then I multiplied both sides by 2. Well, it's not a 2, it's a b, so I multiply both sides by b. But I had to multiply the entire side by b, right? And then all I did was bring the b out front because it looks better. And what do I do now, guys? Well, I don't need to distribute so much. I could. yeah, we're getting the x by itself.
So the x equals
So it's this, D plus C, and then just minus A tacked onto the outside there.
this is a lot.
It's a lot.
For some reason, like it's easy, but it's just a lot of letters to keep track of.
Yeah, well, that sometimes happens in math. That looks sloppy because I'm trying to reach over. Plus C.
I can't even ever see. I can't.
Remember, you can find them.
Because you're like right in.
Yeah,
Right.
that's why I try to keep over here.
I know.
All right.
So move to this desk. Or that desk.
All right, so now we have this 2 times the quantity x minus h plus k equals 8. Solve for, now, solve for x in terms of h and k, right? So all that's saying is you're going to solve it like we did that last one, and the letters will be back, yeah.
Can I move over there so I can...
Yeah, for now. All right.
You just distribute and do it like it's always the same as you would normally.
Well, I don't know that I'd really need to distribute so much. Good.
Oh, this is worse.
I could distribute, but I don't feel like it. Remember, there's a
I
couple
feel
ways.
like it.
Oh, I don't feel like it. Let's just jot this down here real quick. 2 times x minus h plus k equals 8. What should I do first if I don't want to distribute?
Subtract the k.
Let's subtract the k from both sides. So we have 2 times x minus h equals, well, 8 minus whatever k ends up being, right? Just leave it like that. And what would I do now if I don't want to distribute? Let's divide both sides by 2. Right? So what does that leave us with? 8 minus 4. Oh, why did I put a 4? Because you said 4. 8 minus k over 2. And now we can add h to both sides. You know what I might do? Take a look at the answers. Does it look like there's like a big fraction like that in the answers?
No.
So you know what I could do? I could apply the distributive property with this 2. Remember, we kind of did that with division. It's equivalent of like taking 1/2.
Oh, so like negative 2k and...
Well, it's
Or
what?
no.
Right. Remember, this is the equivalent. This is the same as doing this.
Half.
That's positive half.
Or yeah.
It's the equivalent of doing that, right? Isn't it?
BK over.
And so x minus h equals, now let's distribute now. Half of 8 is what?
4.
4
and
minus what?
minus 1. K over 2.
Half times k, or k over 2.
Which is 2. Or no, wait.
You don't know, because we don't know what k is, right?
Okay, so it's 2 then. No, I
Now
have
let's
2
do,
then.
now what do we got to get the x by itself.
Wouldn't the answer be 2 though?
Well, let's get the x by itself. Add h to both sides, yes. So we get x equals 4 minus k over 2 plus h. Right? Well, it may be that they have things in a different order.
H.
Which choice would that be?
H plus 4 minus k over 2.
Yeah, they just use the commutative property, right? Or maybe they solved it slightly differently, you know, right? Okay? So you get the idea with this, dividing by 2, right? And you could just then divide each of these 8 and the k by 2. Okay? No?
No, I'm lost. I don't know.
Well, where did I lose you?
The beginning?
Well, I wrote down the equation. And then I did what we would always
I
do.
don't understand how you get. Yeah. Like I do.
I just subtracted k from both sides here.
No, I mean like.
Okay, I'm trying to get to where, and then when I subtracted the k, look, I just have to write it as 8 minus k, because I don't know what number k is yet. So just leave it in there as a k. And then I do what I always do, divide both sides by 2, right? Well, hopefully you pick it up.
Well, you've gotten the same answer if you distributed first.
Well, sure, yeah, because it's available.
Could you
Yeah.
scroll up to the top one so I can do that one? So yeah, top one.
Okay. So on the next page, now we have a geometry problem. What is that shape over there?
Rectangle.
Okay, it says for a rectangle. The perimeter P, and you know how to find perimeter, right? What do you, huh? Add all four sides up, right? Can be found, the two dimensions of length L and width W are known. So there's L and W. They don't give us any numbers in there, right? Okay, but let's go to part A. Now they give us some numbers, right? So, has a length of 12 and a width of 5. What's the perimeter? Well, do we need to do L plus L plus,
12 times.
this is L, and that's W. Do we need to do L plus W plus W?
12 plus 5.
Yeah, well, sure, we could do that too, right? But what about this? There's two lengths, so instead of L plus L, can we write 2L, right? Now, let me just put the numbers in there. 2 times 12 plus 2 times what? 5, right?
17 equals
24 plus 10,
P equals 34.
34, and it's inches, right? Okay. Now they just want us to kind of do the same thing, but now we just don't have any numbers to put in for L and W, right?
P equals 2L.
Hmm? P equals, well, L plus W plus W.
Yeah, P equals 2L
2L plus
plus
2W.
2W.
Okay? What do they want us to do in part C?
Solve for the length.
And it says rearrange the formula. That's really a strange way to word it. They want us to solve the formula we just wrote for what letter? L. We want to get the L all by itself. And then determine what it is when the perimeter is 20. Okay? So let me just, I'm going to copy this down. I want my L over on the left side. 2L plus 2W equals P. You guys
Well,
okay
it'll
with
be-
that? So what should we do first?
Plug in.
No. They want us to solve it first. Subtract 2W from both sides. And that leaves us with what? 2L equals P minus 2W. Okay? And finally what? Divide both sides by 2, right? And so we get L equals P minus 2W over 2. And maybe we could simplify that by, as we're distributing the 1/2 through there, right? But we could just leave it like that for now. Okay, so there's the formula. Does anybody have any questions on that? Okay? We have to leave, right? If we had numbers in there, we'd just have, single number answer. And this is useful, right? Like if you have a bunch of problems where you have to solve a rectangle for its length, instead of going through and solving this, rearranging it and for L all the time, get it done once and then do it however many times, right? So let's plug in. Determine the value of L when P is 20. So what do? We just plug into this thing, right? So L equals, what do I write? 20 minus what?
Minus 2 times.
2 times 4, 2 W's, right? Oh, yeah. 4 in there, because then we know. All over 2. Okay, so that's 20 minus what? 8. Well, no, I said minus, right? If it said minus negative,
Yeah, you
that's
can't say
plus, yeah.
minus, though.
Now, why are you copying any of this down? Okay. Over 2?
Yeah.
Well equals 12 over 2? 6. They didn't give us any units, so. Okay? So this would be handy, like if you had a bunch of them where you had to find the length, give them the perimeter and the width, it'd be convenient to take this out of its current form one time with L, right? Does that make sense? Yeah, you'll find that in science frequently, okay? One last complication here they talk about. What is that? Okay. So here, like on the front of the page, they give us an equation like we normally solve, and then over here, with just the letters, a literal equation. Okay. So this one is going to be a little twist in this one. Let's solve the first one first and see what we're doing. So we need all our variables on one side, right? So let's subtract 5x from both sides. Can we do something else at the same time? Subtract the 1, get that right? So we get 3x equals 21, right? Divide by 3, x equals 7. All right, let's see what happens in this other one when we go to do it. Okay? You see, you know how we like combined like terms here, 8x minus 5x? That's nice because you had 8 of them and took away 5 of them, right? And we're left with 3 of those x's. But what if we don't know it was 8 and 5? Well, let's try it. So let's go here. What should we do first?
Subtract the b and subtract the cx.
Yeah, let's do it. We'll do them both at once. Then minus b, right? Just like I did over here. Okay?
So,
But, right, we're over here. This was 8x minus 5x. I don't know what it is. So it's just going to be ax minus cx, isn't it? Equals, that goes away, d minus b. What the heck should we do now? Hmm? How am I going to... You see your mom?
yeah, I did. I said that too much.
All right.
$5 every time I said your mom.
So how are we going to solve this for x if we can't combine those like terms? Anybody have an idea? Something you know how to do?
Divide.
In a roundabout way, yeah. Well, then put it back on the right-hand side.
Divide x by a, and then you'll get d minus a.
Well, what about c?
Then you just put the c over, like you divide by negative c, which would be a minus c.
Wait, if we divide, well, okay, listen. I can't just divide, so everybody don't write this down. So listen, here's what she suggested, that we do this first, like that.
Yeah.
But if you divide like that, you have to divide every single term.
Why don't you just do one line and then...
Well, hold on, you get what I mean? And then that would be, then you'd have x minus c over ax. And it gets even more messy, right? So we need to think of something different. What, let me ask you, what does this look like the equivalent of doing? We've done it quite a few times. What does this look like the result of being done? Oh, it looks like something that was distributed to get this. What's the opposite of distributing? Starts with an F. Keep it clean. Factoring. Factoring. You guys get what I think about that? Is there something I could factor out of these two terms? Do they have it? Oh! Whoops, I don't want red anymore. So if I factor out an x, what's left inside the parentheses?
A minus c.
Okay. Now I have this single x here. What can I do now to solve for that x? Well, then right back to where I started. Huh? Divide both sides? No, not by x. I want to keep the x. Well, x is being multiplied by this a minus c. What undoes multiplying by a minus c? By?
A minus c.
Right? So these cancel, right? And you get x equals d minus b over a minus n. I don't really need parentheses there because it's already horizontal lines, a grouping, something, right?
I'm definitely gonna fail the regions if this is on it.
Oh, yeah.
I'm not even gonna make it to Regents.
Why is math
You
so
have a terminal
complicated?
disease or something?
Yeah.
Okay.
Yeah. Not me, he's asking about him. He said
All
he's
right.
not gonna make it.
Let's take a look at this one. Now, listen, by the way, something happened here where this question here, these things are not even close to the end. They're not, right? So we're just gonna work this one through
Why'd you cross them all out?
because there's some kind of error. Hey, there's some kind of error here, and these choices do not apply to this, okay? So they want us to solve that thing for what up there?
A minus AF.
For x, right? So let's just jot it down somewhere in the middle here, I guess. A
Being, like,
minus,
apparently the best way to do math. They sure do make a lot of mistakes, don't they?
yeah. Well, I don't know who said it was the best.
Oh, well, no, like they.
Do you know we're trying to cancel math?
Cancel math?
Yeah.
Wow.
It was on the news. Okay, so I think we should
I don't know.
divide each side by 3. I don't know. I read it on the news.
Well, listen, guys, listen to me. There's x's on both sides, so what does that mean we really need to do?
Distribute.
We need to distribute to get the x's so we can get all the x's on one side, right? So let's go ax minus k equals what?
3 minus
3x plus 3h, right? Now what? Subtract the 3x from both sides?
Then you're left with like a very
Got it.
on each side.
And let's add k while we're at it. So ax minus 3x, right? 3h plus k. Okay, does this look a little like the issue we had up top, up above?
Yeah.
So what can I do here? Factor out the x, right? So x, what gets left? A minus 3
Equals 3.
plus k, right?
Divide by A minus 3.
Divide both sides by a minus 3, right? Because that means that'll cancel and that'll cancel, and we'll get x equals what?
3H plus K over A minus 3.
Okay? All right, see, I know those answers were anywhere in the ballpark of that. Actually, I think these are the answers from the multiple choice, but some of the page before. Okay?
This makes me want to quit math.
Yeah, wanted to just drop out
Okay.
of every.
Hey, feel free to stay stupid. Spend some time with me and fix that.
That reminds me.
Yes,
My
but
GED.
if I'm not learning anything, this seems like a job.
All right, so here's a formula. and It's a formula from a physics class, okay? So,
my.
it's not. So these all have subscripts on them, right? That's V sub F, V sub. So V in physics generally stands for velocity, right?
I don't know.
And in a lot of cases, well, V, velocity, speed. So in many problems, you have to deal with two different velocities. One would be like something starting or initial velocity, and then its final velocity. And so we just put little subscripts on here so we know which one is which. So that V sub F would be the what? Initial or final? Final velocity, and V sub I would be the initial velocity, right? All over T, and A is acceleration, like how fast does it get up to speed, that's all. So you have a starting speed, and then the top speed, divided by time, and that's the acceleration. So it could be that the initial, like a car started out at 20 miles an hour, initial velocity, and accelerated to 60, final velocity, and how long did it take to get from 20 to 60? Divided by T, right? Well, I don't know, okay? But anyway, So that's the formula. I mean, you don't really need to know what that formula is. I'm just telling you what those subscripts are because you looked at it and you don't see this too often yet, right? But you will. They're just different variables. So what do they want us to solve for? Solve, it's probably right after the word solve the formula for.
Final velocity.
Yeah, it's already solved for A. Who said it? They want us to solve for V sub F in terms of initial velocity, V sub I, acceleration, A and T time. Okay, well, let's jot the, I'm going to write it down so the variable I want is on the left. You don't have to do that, but I like to do that. So V, you got to make it look like a subscript, right? Minus V sub I all over T equals A. So I'm going after that V sub F there, final velocity.
How do you make it look like a subscript? Can I just
Right, I'm really
Small,
tiny.
really small and below.
Yeah, tiny. Whoa. It's kind of like the opposite of an exponent, small and up, small and down. That's a superscript, that's a subscript.
In chemistry, like H2O, like.
Yeah, chemistry has a lot of subscripts
that
too.
deleted here equals?
Oh. All right, so I want to solve this for V sub F. What's the first thing I should do to both sides?
Multiply by T.
Multiply both sides by T, right? So these would cancel. I'm left with what?
V
VF
minus V
minus VI
equals
equals AT. Now what?
add the V.
Add VI to both sides. Right? And so I get what? V sub F equals what?
Wait, where does the T go though?
Right there.
Stays there.
I am so stupid. I was
It
thinking
canceled.
it was going up just to the
Okay.
subscript.
What does VF equal?
AT plus.
Plus initial velocity, VI. Okay. So they're just variables of subscripts. You guys saw them there. You got your knickers all twisted up.
V
Okay?
is
You got that? Plus VI.
Mine had her.
Let's look at the next one. Formula for determining the finite sum of an arithmetic. We haven't done arithmetic sequences yet,
Huh.
but we'll get to that later. So don't even worry about what that is at the moment. Okay?
What they call
Arithmetic sequence. There's arithmetic sequences and geometric sequences.
It looked like arithmetic. Not arithmetic.
Well, arithmetic would be MAT. That's a noun. Arithmetic is an adjective that describes the type of series. So they change it. So here is the formula. S equals N over 2 times the quantity A plus B. N's the number of terms, A is the first term, blah, blah, blah. You don't need to know that. What do they want us to do? Solve it for what? No.
V.
There's not even an X in there. They want us to express B in terms of S and N, so we have to solve for B.
Okay. S.
In terms of A, yeah. So let me rewrite it the way I like to do. And again, you don't have to do this. I do. Number 2 times A plus B equals S. Okay. Well, do you guys remember what, so we want to get rid of that fraction in front. Do you remember what we can multiply both sides? and make
2
one?
over.
The reciprocal, right? Because we want to undo multiplying by n and also undo dividing by 2. Right? So we're going to multiply both sides by
2 over N. A plus B.
so these guys will cancel. And what are we left with?
A plus B.
Equals, we'll just call it 2s over n. It looks better. Okay? Instead of s2. And finally what?
Subtract B.
Subtract b from both sides. With the b, won't combine in there, so it's just going to have to get tacked on, right? So what is a?
2A equals 2S and minus B.
2s over n, right? And then just minus b at the end.
Am My S's look like a 5. So
Yeah, that's why I don't really like using S's a lot of times in variables. That's, yeah. It almost looks like 25 over n, right?
Yeah,
So-
yours does.
Mine does too. That's how I write my S's.
I
I
do
think it would look more like an
pretty-
S, I think. Okay.
It's dot.
Yeah, this.
And the next year, you guys in geometry will be using a formula like this. You've probably done this before, volume of a cone.
Yeah, I did this last year.
Remember pi?
Yeah.
Remember what pi is, guys?
3.141.
Yeah, that's an approximation. It goes on decimal forever. It's transcendental. Pi is actually not a number somebody made up. It is the circumference of any circle divided by its diameter.
Isn't that pi?
That's part of it, yeah. It goes on infinitely.
Yeah, down there.
So here's our formula for volume of a cone. And what do they want us to solve for in that
E,
formula?
R, and N.
No,
H.
right. Again, guys, when you're looking to read a sentence, you start where you see a capital letter, right? And then go to the period, see? Okay. So we need to solve this for H, don't we? Let me do this. So 1/3 pi r squared. Oh, do you guys know how to undo squaring?
Square root.
Yeah. I want to just real quick make sure we're on the same page. We got to go back a page, right? Real quick here. Oh no, we're not. No, scratch that. We're not solving for r. Never mind. We don't need that right now.
We're solving for H.
H, and H is not squared, so don't worry about it.
Aren't we supposed to be smart?
Okay, what should we do?
1/3 times.
Let's
Multiply by 4.
yeah, let's start out with that, right? And then what does that leave us with?
Pi r squared H equals 3b.
Let's call it 3b. And I want the h by itself. It's currently being multiplied by pi r squared.
Unsquare r.
No, I don't need to unsquare r. I want h. I don't need to unsquare r. If I was solving for r, I would. H is being multiplied by those two things. So how do we undo that?
Divide by pi r.
Divide both sides by pi r squared. When the pi's cancel, when the r squareds cancel, what am I left with?
H equals 3.
There you go. Okay.
Is math actually your favorite subject?
Is there a dot? Is there like a multiplication dot after the r squared on the second line?
No, just squared as an exponent.
Oh.
No, I was just doing that too. You don't really need it when you have letters there. You usually use that dot if you have like 3 times 5 times 9, so it doesn't look like a 359, right? Okay. All right, so before we get to this one, I do want to give you a quick note. On the swearing. So flip, you got to go back a page to the notes page there. Okay. Here's the note. You guys know that how do we undo squaring something? Take the square root, right? So if I have x squared and I want just x, like if I'm solving for x, I should take the square root of x squared and they undo each other. And what does this equal?
Oh my god.
Just x, right? What if I want to undo square root? Bless you. What if I'm taking the square root of x and I want just x? What should I do to that? What undoes square root? Squaring. So then I would just square it, and what's the result should just be what? X. So squaring and square root are inverses of each other. They undo one another, just like
That's weird.
multiplication and division undo each other. Okay? No big deal. We got that? So if you're solving something, right, and you end up getting x squared equals blah, 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 you just take the square root of both sides. All right? Let's go back over here, down to number 4. Okay? So again, more physics. Power, current, electricity, okay? Anybody in here do any study electrical circuits at all?
No, we can't.
Voltage, current, resistance?
Oh, yeah, I found out after holiday.
Yeah, that's no picnic, is it?
I, one time, actually like 3 times, I got struck by a horse fence.
Yeah, well, there you go. So you could have modeled it with, you could have modeled that horse fence shocking with this, Tegan. Power of the fence that zapped you equals the current squared times the resistance of the fence. And all materials that conduct electricity have resistance. Huh? You
My
what?
cow fence is a really old fencer,
Yeah?
and it doesn't shut off for 5 minutes after you unplug it.
Oh,
So I touched it not knowing.
there must be a capacitor involved somewhere. Yeah. Okay. So here's our formula. P equals I squared R. I is current, R is resistance, P is power. Okay? And they want us to solve that for what?
I got I.
Well, that's weird. The formula, oh, yeah, for I. So they want us to solve it for what? Okay, so let's do I squared R equals P. Remember, reverse PEMDAS. What should we do? Solve. I have nothing to put in. Divide both sides by R.
It says P equals 1.
Right? What does that leave me with? I squared equals P over R. Okay? I don't want I squared. I want just I by itself. How do I undo the squaring of that I? I take the square root, but what I do to one side, what? Just like everything else. Okay? And so what does that give us then? I equals square root of P over R. Simple as that. So choice 2. Oh, that's what you meant by 2. I kept thinking you were going to say 2, like you got some numerical that no. Choice 2. Okay, I got you. Okay?
They should really make it A, B, and C. Actually, that's not what they should do.